Hi everybody, today we're going to talk about chapters 20 and 21. We're going to do a little bit of each of the chapters. Chapter 20 talks about oxidation and reduction reactions, and then 21 talks about electrochemistry, which involves oxidation and reduction reactions. So as usual, you have your poem and then the learning targets on the first page. Let's go to the next page. So oxidation reduction reactions are pretty much most reactions. They are reactions that involve the transfer of one or more electrons. So if you think about it, a lot of our reactions are redox reactions. Batteries operate using redox reactions. Combustion, those are redox reactions. Synthesis, decomposition, single replacement, metabolism, when you digest food, rust, corrosion, thermite reactions. So pretty much almost all reactions. The only reactions that are not redox reactions are double replacement reactions. Any other type of reaction is considered a redox reaction where electrons are transferred. And that's why electrons are so important in chemistry. If you remember at the beginning of the year, we spent a lot of time talking about electrons and electron configurations and what happens when you transfer electrons, and that's because most chemistry happens because of the transfer of electrons. Now, to help us figure out how the electrons are transferred, or where they're coming from and where are they going, to help keep track, we use something called oxidation states or oxidation numbers. So you could call these oxidation states or oxidation numbers. And these are just basically numbers that help us keep track of electrons in a chemical reaction. Sometimes if something is charged, the charge will be your oxidation state, but we assign oxidation states to all species even if they don't have a charge. So let's write that down. So they are numbers that help us keep track. What says keep there? Of electrons in a reaction. And there are rules for assigning oxidation states. There are 8 rules, and you do need to know those 8 rules, but I think a lot of them will sound familiar to you. They're pretty easy to remember. So let's go through them. Number 1 says free elements are assigned an oxidation state of 0. So if you ever see an element in its natural state, like Al or Na or Fe or H2 or O2, any diatomics are going to be with 2s. Those have an oxidation state of 0. So if it's a neutral element by itself, it's going to have an oxidation state of 0. Number 2 says that the oxidation state for any simple one-atom ion is equal to its charge. So, for example, let's say you see Na by itself, like that. That would have an oxidation state of 0. But if you see Na with a positive charge, that charge is its oxidation state, so its oxidation state is +1. So if you have any one-atom ion, one atom that has lost or gained electrons and it has a charge, that charge is its oxidation state. Let's look at number 3. Number 3 says the alkali metals in compounds are always assigned an oxidation state of +1. So again, if you see just sodium by itself, which is an alkali metal, that has an oxidation state of 0. But if you see it in a compound, like for example, let's say you have NaF, so that sodium is in a compound, so its oxidation state is +1, which makes sense because alkali metals, when they're in compounds, they're going to have a charge of +1 and therefore an oxidation state of +1. Next rule says fluorine in compounds is always assigned an oxidation state of -1. So if you see fluorine in its natural form as F2, that would have an oxidation state of 0. But if you see it in a compound like NaF, for example, then it would have an oxidation state of -1. Number 5 says the alkaline earth metals, so group 2, and also zinc and cadmium, when they're in compounds, they have an oxidation state of +2. So if you see magnesium, for example, by itself, that would be 0. But magnesium chloride, for example, that would be a +2. So for example, this calcium and calcium sulfate is +2. Similarly, aluminum and gallium in compounds are +3. So if you see just aluminum by itself, it has an oxidation state of 0. But if you see it in a compound, it's a +3. Rule number 6 says hydrogen in compounds is assigned an oxidation state of +1. There is an exception to that, which is hydrides. Hydrides is when you have a metal bonded to the hydrogen. So for example, lithium hydride. So in lithium hydride, the Li is a +1, so that must mean that the H is a -1. So hydrogen by itself right here would be a 0. In a regular compound like H2SO4, it would be +1, but in a hydride where you have a metal bonded to it, it would be a -1. Next, it says oxygen in compounds is assigned an oxidation state of -2. The exception to that is if you have peroxide like hydrogen peroxide, then it's -1. So O2 in its natural form, that would be 0. In a regular compound, it would be -2. The exception to that is a peroxide, it would be -1. Honestly, the only peroxide you need to remember is hydrogen peroxide, and that would be a -1 in there. The last rule says that the sum of the oxidation states of all the atoms in a species must equal to the net charge on this species. For example, if you have HClO4, that means if you add the oxidation state for hydrogen plus the oxidation of chlorine plus 4 times the oxidation state of oxygen, that should equal to 0 because this is a neutral compound. Its charge is 0. If you have something like chromate ion, CrO4 2-, then that means if you add up a chromate, its oxidation state, plus the oxidation state for 4 oxygens all together, they're going to equal to -2. And the oxidation state is per atom. Each atom has an oxidation state. So let's practice some of these. We'll start with LIBR. So we have a lithium and we have a bromine, and so we need the oxidation state of each thing. So lithium, there's a rule for it. I believe it's rule number 3. It says that the alkali metals in compounds is a +1. So lithium is going to be +1 in this case. Bromine, there's no rule for it in compounds, but we know from rule 8 that together it needs to equal to 0. So that makes the bromine a -1. Okay, let's look at B, MgI2. So MgI2, we have magnesium and we have iodine. Rule number 4 says the alkaline earth metals in compounds is a +2. There's no rule for iodine, but together a magnesium and 2 iodines need to equal to 0. So that means that each iodine is a -1, so that when you add them up all together, it's equal to 0. Let's look at CH2O. So we have hydrogen and we have oxygen. Rule number 6 says that hydrogen in compounds is a +1. Rule number 7 says oxygen in compounds is -2. Together, if you add them together, 2 hydrogens at a +1 each, plus an oxygen at a -2, that yields 0, which makes sense because water is a neutral compound. Let's look at H2SO4. So now we have hydrogens, we have sulfurs, and we have oxygens. Rule number 6 says that hydrogen in compounds is a +1. There is no rule for sulfur, so let's skip it for now. Oxygen, rule number 7 says it's -2. So we need to figure out what sulfur is. So what you're going to do is you're going to say you have 2 hydrogens, each are +1, plus 1 sulfur, we don't know what it is, so let's call it X, plus 4 oxygens, each are -2. Altogether, that is going to equal to 0 because it's a neutral compound. And you solve for what X is. And so if you solve for X in this case, it's a +6. All right, let's look at the next one, Fe2O3. So we have iron and we have oxygen. There's no rule for iron, so let's skip it for now. There is a rule for oxygen. Number 7 says that oxygen is going to be -2. So we have 2 irons. So I'm going to say 2 times X plus 3 oxygens. Each are -2. The total is equal to 0. And so that means that the iron in this case is a +3. Okay, CuF. We have copper. We don't have a rule for copper. We do have a rule for fluorine. It's a -1 in compounds, so that makes the copper in here +1. CF4, carbon we don't have a rule for. Fluorine we do. It says that it's -1 in compound. That's rule 4. And so that would make the carbon +4 because we have 1 carbon and 4 fluorines, and altogether they need to equal to 0. Let's look at WO2, tungsten. We don't have a rule for. Oxygen we do. Each oxygen is a -2 according to rule 7. So altogether they need to equal to 0, and so that makes tungsten +4. NO3 minus is next. So we have nitrogen. We don't have a rule for nitrogen. We do have a rule for oxygen. It's -2. And so we're going to say X, which is the nitrogen, plus 3 times the oxygens. So each oxygen is -2. That altogether is equal to -1 because the total charge here is -1. And so that X, or that nitrogen, must be a +5. Last one, PO4 3 minus. And so we have phosphorus, we have oxygen, no rule for phosphorus, oxygen is -2. So we need to figure out what phosphorus is. So X is your phosphorus plus 4 times -2. Altogether is equal to -3 because the total charge for the phosphate is -3. And so that makes X a 5. So phosphorus is +5. So we said that oxidation reduction reactions involve the transfer of 1 or more electrons. One substance is losing the electrons, the other substance is gaining the electrons. So we're going to use these oxidation states that we just practiced in order to figure out what is getting oxidized, what's getting reduced, and what's happening to the electrons. So let's define reduction and oxidation. Reduction is actually much better named than oxidation. When you think oxidation, you think you're adding oxygens, but that's not really the case. Oxidation actually means that the charge is increasing, or the oxidation number is increasing. Reduction means the charge or the oxidation number is reduced. And so reduction is actually much better named. So I always think of what's reduced first, and then I come up with the oxidation. So let's write that down. So reduction means the charge, oops, that's A there, or the oxidation number is reduced. What does that mean? So if your charge is reduced, so let's say you go from 0 to -1, that's reduced, that's getting smaller. Or from +2 to +1, or from +2 to 0. So your charge is going down. you are becoming more negative or less positive? Well, in order for this to happen, electrons are being transferred. So if your charge is reduced, would you gain electrons or would you lose electrons? Remember, electrons are negative. So if your charge is going down, that must mean that you are gaining electrons. You're gaining negatives. So if you're 0, you become -1. If you're -1, you become -2. If you're +2, you become +1, and so on. So your charge gets reduced, your oxidation numbers goes down. That means you gain electrons. So reduction is actually gain of electrons. Oxidation is the opposite. Oxidation is when your charge or your oxidation number is increased. So you can go from 0 to +1, for example, or +1 to +3, something like that. So remember, we're talking about electrons here, and electrons are negative. So if you are becoming more positive, if your charge is increasing, that must mean that you are losing electrons. So oxidation is actually loss of electrons. One way to remember that is the saying, Leo the lion goes grr. So Leo stands for loss of electrons is oxidation. Grr stands for gain of electrons is reduction. So that's one way to remember it. Biologists like oil rig instead of Leo goes grr. Same thing. So oil stands for oxidation is loss. Rig stands for reduction is gain. Chemists prefer this one because you're talking about electrons there. That E helps you figure out you're losing electrons or gaining electrons, whereas oil rig, what are you losing or what are you gaining? But either one, if it helps you to remember what oxidation and reduction is, that's great. Use that. In order for reduction to happen, oxidation has to happen simultaneously. Because in oxidation, you're losing the electrons. So one substance loses the electrons. Reduction means you gain the electrons. Well, if something loses the electrons, those electrons have to go to somewhere, and so they go to another substance that gains those electrons, so reduction happens as well. And so in order for one to happen, the other one has to happen simultaneously. So something gets oxidized, something gets reduced. Let's look at an example here, and then we'll come back to what reducing and oxidizing agents are. I know those are not on your paper there, but we'll talk about them. So let's say that I have this reaction happening. I have some elemental magnesium, some metallic magnesium, and I add oxygen to it, and I form magnesium oxide. I want to know what substance is getting oxidized, what substance is getting reduced, which one gained electrons, which one lost electrons. We'll figure out what oxidizing and reducing agents are in a minute, and then how many electrons were transferred. Since redox is the transfer of electrons, how many electrons were lost and gained or transferred. So the way that you figure this out is you assign oxidation states to every single species in your reactants and in your products, and you look at which ones changed their oxidation states. So let's do that real quick. So the magnesium in the front here as your reactant, this is just elemental magnesium by itself. So what oxidation state would it have? It would have an oxidation state of 0 because it's an element all by itself. Let's look at oxygen as an O2. Again, this is an element in its natural form, so that would also have an oxidation state of just 0. Okay, let's look at the products now. How about that magnesium in the magnesium oxide? Well, magnesium in compounds, or second group elements in compounds, would be a +2. I believe that's rule number 3. And then oxygen in compounds is -2. That's rule number 7. Okay, so after you assign oxidation states, you look at which ones changed. So let's look at our substances. We have magnesium and we have oxygen. So magnesium went from 0 in the reactants to +2 in the products. Oxygen went from 0 in the reactants to -2 in the products. So you want to ask yourself which one got reduced, which oxidation state got reduced. It went down. So which number went down? That would be the oxygen. It went from 0 to -2, so that means the oxygen was reduced. So then which one went up? That would be the magnesium. It went up. It went from 0 to +2. So to answer letter A, you would say the substance that got oxidized would be the magnesium. The substance that got reduced would be the oxygen. Okay? Letter B says which substance gained electrons and which substance lost electrons. So you can memorize Liouville's-Guhr, or you can remember that oxidation is loss of electrons, reduction is gain of electrons, or you can figure out from the charge. So the magnesium went from 0 to +2. Its charge went up, so that means it lost electrons. Or, again, you can just go with Liouville's-Guhr. If it lost electrons, that's the oxidation, and this one was oxidized, so that means it lost electrons. So this one lost electrons. The oxygen, because it got reduced, gain of electrons is reduction, so that tells us that whatever got reduced, which is the oxygen, that gained electrons. Okay, letter C says, what is the oxidizing agent and what is the reducing agent? These are a little bit confusing. Think of a travel agent. What does a travel agent do? A travel agent helps somebody else travel. They don't necessarily travel. The travel agent doesn't have to travel anywhere, but they help someone else travel. They cause someone else to travel. And so a reducing agent does not get reduced. A reducing agent helps something else gets reduced. Let's write that down. So a reducing agent is a substance that causes reduction or causes something else to be reduced. So it causes something else to gain electrons to be reduced. Well, if it's causing something else to gain electrons, that means it itself is losing those electrons to force something else to gain them. And so it itself is getting oxidized. It itself is oxidized. So something that's oxidized is losing electrons, so it's forcing something else to gain those electrons, so it's forcing something else to reduce, and so it is a reducing agent. It's causing reduction to something else. Similarly, an oxidizing agent is something that causes something else to be oxidized. So it is a substance that causes something else to be oxidized. So it's causing something else to lose electrons. So it itself is gaining those electrons. It itself is reduced. So this is a substance that's reduced. It's gaining the electrons. So it's making something else lose the electrons so it can gain them. And so it's causing something else to be oxidized. So it's a little bit confusing because it's the opposite. So a reducing agent is what gets oxidized. the oxidizing agent is what gets reduced. So to answer the question here in C, let's see, the magnesium got oxidized, so that means it caused something else to be reduced, so it is the reducing agent. The oxygen got reduced, and so it caused something else to be oxidized, so this is the oxidizing agent. All right, last question says, how many electrons were transferred and from where to where? So you can figure this out by looking at just one substance here. You could either look at the magnesium or the oxygen, you would still get the same answer. Let's look at magnesium first. So magnesium went from 0 to +2. That means it lost electrons. How many electrons did each magnesium lose? Well, if it went from 0 to +2, that means it lost 2 electrons. But there are 2 magnesiums in my reaction, so that's a total of 4 electrons lost. Okay, let's look at oxygen. We should get still the same answer. Oxygen went from 0 to -2. It got reduced. It gained electrons. How many electrons did it gain? Well, for oxygen to go from 0 to -2, it must have gained 2 electrons. But there are 2 oxygens here, so 2 times 2 is 4 electrons gained. The number of electrons lost by the magnesium needs to equal to the number of electrons gained by the oxygen. So 4 electrons were lost from the magnesium and went to the oxygen. So let's write that down. 4 electrons transferred from magnesium to the oxygen. All right, let's try one more. Let's look at number 2 here. We have calcium nitride decomposing to form calcium and nitrogen. So remember, the way that you figure out what's oxidized, what's reduced, all that stuff is by assigning oxidation states or oxidation numbers. So let's do that together. Calcium nitride. So calcium here is in a compound, and so its oxidation number or oxidation state is +2. Let's look at the nitrogen in the calcium nitride. Well, there's no rule for nitrogen, but in order to make that compound neutral, each nitrogen there needs to be -3. Okay, let's look at the products. That calcium is by itself, it's in its elemental form, so it would have an oxidation state of 0. And that nitrogen also is by itself in its elemental form, so it has an oxidation state of 0 as well. Okay, so let's write them down here. So calcium went from +2 in the reactants to 0 in the products. Nitrogen went from -3 to 0 in the products. Okay, you always ask yourself first, which one got reduced? So the number that got reduced, that would be the calcium. It went from +2 to 0. It got smaller. The oxidation would be the one that got higher, that increased. That would be the nitrogen going from -3 to 0. So the calcium got reduced, the nitrogen got oxidized. Okay, let's look at letter B. Which substance gained electrons and which substance lost electrons? Leo goes GR. Loss of electrons is oxidation. So whatever is oxidized lost electrons. GR, gain of electrons, is reduction. Whatever got reduced gained electrons. Okay, letter C. Which one is the oxidizing agent and which one is the reducing agent? So calcium got reduced, so it's the oxidizing agent. It caused something else to be oxidized. Nitrogen got oxidized, so that means it caused something else to be reduced. It is the reducing agent. The last question says, how many electrons were transferred and from where to where? So let's check. Let's check calcium. Calcium went from +2 to 0. So gained electrons here. Each calcium must have gained 2 electrons to go from +2 to 0. But there are 3 calciums. So if each gained 2 electrons, 2 times 3 would be 6 electrons were gained total. Let's look at nitrogen. It should give you the same answer. Nitrogen went from -3 to 0. It lost electrons. To go from -3 to 0, the difference is 3 there, so it lost 3 electrons. But there are 2 nitrogens. 2 times 3 would be 6 electrons lost total. The electrons gained need to equal to the electrons lost. There are a total of 6 electrons that were transferred, lost and gained. They were lost from the nitrogen and gained by the calcium, so they went from the nitrogen to the calcium. All right, this is it for today. Tomorrow we will learn about balancing redox. Have a wonderful rest of your day.